Well, it's about the floating wind turbine model. How long do you think it will take to get this? And will it be just a numerical model, or also a physical model? That's to say, with a couple of experiments in a tank test and in a wind test also.
That's a good question. So the design of the floater for the 15 megawatt, there is a design now that's being done by our US colleagues as part of a broader project that they have with ARPA-E. I know that some testing, et cetera, is involved with that, but I don't actually know offhand what the specific plans are within that project. So for sure, a numerical design, and I don't know if they're doing any scale testing with that specific design or not. In the Core Wind project as well, the EU Core Wind project, which DTU Wind is involved with and also is coordinated out of Spain. There is also a design in development for the 15 megawatt, and I do not think there are plans with that one to do scaled testing, but I'm not sure. But generally, I think the idea with the reference turbines and how we've set them up on GitHub is that they'll have variations of the designs so that different floating designs can be added on. That's the nice thing about GitHub. It allows you to have different, iterations and versions and extensions. So hopefully as the turbine is now released and available, we'll see kind of a development of a series of potential floaters for it, just like you had with the NREL 5 megawatt turbine many years ago. And that machine, of course, is quite outdated now, but it's been used as a workhorse for doing floater designs for years. So that's the hope with this new one.
Okay, thank you very much, Catherine. Other questions from Salvi or Nicolas, or from the list? I don't see in the list. Okay. So now questions for. Yes,
there's a question. There's a question for Catherine from Leo Dalma from Leo Dalma, yes, Supergrid Institute, sorry, a colleague in terms of status of the research institute. So the question is, Catherine, what is the role involvement of the wind turbine OEMs and plant developers in task 37?
Catherine, we can't hear you. Catherine, you have to put your mic on, I guess.
There we go. Yeah, we have representatives from both OEMs and developer owner operators that are active in the task at different levels. And so a lot of the industry role is in sort of an advising capacity. They give us input on, for example, the reference turbine design. We did a survey to industry in terms of defining the specifications for the machines, both for the 3.4 and the 10 and the 15 megawatt. So we iterate with industry on all of our activities, especially to make sure that the material that's coming out is industry relevant. We've had industry participate directly in some of our case studies, oftentimes using their own in-house proprietary tools, and so then they can compare to what they get from the research community side in terms of the optimization case studies. And we've had their input as well on the ontology development. So They are active in the different work packages, often attending the meetings, providing detailed design review feedback and other, and in some case actively participating in some of the activities.
Great, thank you. See any other questions for? Okay. So now, please, Nicolas, can you answer to the couple of questions that have been raised to, been asked to you?
Well, it's a bit mixed up with technical problems, so we're a bit struggling to find
the actual questions. Yeah.
I have highlighted them. I think the first one is from Anne Blavet,
Yes.
about diffusion project, asking about which algorithms are used for the layout optimization, and also some figures about computation speed. Just remind us, the Diffusion Plus project is a collaborative project, so we have the responsibility of 3 modules at France Énergie Marine, but layout optimization is not one of them, but yet I can give some answers. This module has been developed by the University of Aalborg, and 4 algorithms are available for optimization, and namely brute force, covariance matrix adaptation evolutionary strategy, which is an evolutionary algorithm, Monte Carlo, which is a probabilistic stochastic approach, and a meta-model based approach, which has not been validated yet, this final one. And the covariance matrix adaptation is evolutionary algorithm like genetic algorithm, but it's normally faster. And in terms of figures, I will give you the link of what from the reference from which I am taking this information, which is a deliverable of the project available online publicly. And this genetic algorithm is normally takes around 300 to 500 iterations to find a solution, while a classical genetic algorithm lasts 2,000 to 5,000 iterations. So this is for this first question.
There was a question of the availability of the results and any presentation of the projects online. So I guess this you can provide also an address that will be shown to everybody for the deliverables.
Yes. I think I will just after putting the question, the link for if you type DTOcean on Google, you will find it quite quickly. But we will provide the direct link. Next question.
Same
I guess
question
is about
for Valérie. Yeah.
Yes. Project deliverable are available for a member of the project and internally in France Énergie Marine. There have not been there has not been any public publication about it, but we can discuss it if you are interested in some specific result. We can provide the list of deliverable and discuss what can be done. Next question.
A question by Matthew Stopper about, I think what are the, yes, in Valérie, you were also quoting some of the algorithms of DTOcean on what has been changed from the tidal models to the wind models.
Actually, there is no big change except for fluid density and maybe orientation of the turbine used. Reference position. The idea was to produce our own layout optimization, to add our own tool that we can use internally, even if we reuse it. And so there have been has been no major change to it, except extracting it and using it and playing with it. And if I down another question, there is another question about algorithm for DTOcean, which we have responded, and again for Valérie findings. Here we have a new question for Catherine from Carole Le Gorgeux. How often are the reference machines updated? The 15 megawatt turbine was released last year. When will be the next update? I think partly answered.
Yeah, that's a good question too. So you know, the idea is to produce a series of reference turbines that sort of meets you know, the needs in terms of representing the current commercial or near future technology for the industry. And so, you know, one of the reasons we have this activity in the task is that the 5 megawatt turbine from NREL that was developed really, you know, 15 years ago, 10, 15 years ago, it's been around for so long, and technology has changed so much from when it was first developed, but it's been really useful having that common representation. So the idea is to introduce new reference turbines as there are needs to kind of reflect the technology change that's happening. So I think potentially the next machine that we'll likely look at is something that's very, very low wind speed, and primarily for land-based applications, as that has been a significant trend in the last several years. And even though the low wind speed turbine we developed had quite a low specific power, around 230 watts per square meter, it's still not as low as we're seeing coming from industry going forward. So for offshore, 15 megawatts is you know, fairly large size machine, so probably will reflect the state of the art for at least a little while. But there's already been discussions about potentially doing a 20 megawatt size machine. There's always potential to do variations of the 15 megawatt for different drivetrains. We already talked about platforms and things like that. So these reference designs are kind of living entities, and you know, once we release them, they kind of take on a life of their own as needed by the community.
Okay.
Yeah, thank you. And as you mentioned, while some floaters will be designed for the floating industry, some variation will be done, and it's what we can take advantage of in GitHub. Yeah.
Okay. So now we give the floor to Salvi to answer to some of the questions that have been raised. I think one by Carole Le Gorgeux. What's the electrical layout optimization exercise requested by the owner or the developer? Has the exercise been extended to other wind farm projects?
Oh, that's a good question. Do you hear me? Yes, it's working, because I have some issues. Okay. This work has started 10 years ago. So 10 years ago, that was more a question for developers, integrators, developers of parks. And the idea was to stay tuned to what the market could be and what the technology could be, and some new technologies could arise and so on. So today, the owner, maybe the owner in the question is the owner of the park or the developer of the park. Maybe sometimes today it's the same operator, it depends. But it's more or less a question of, yes, developing an integration. Second question, has the exercise been extended to other wind farm projects? Yes, of course, we did it on many different sites. The idea is to get enough information as we need to be sure that the calculation is okay. And it is sensitive to the configuration of the parks offshore. Several cases have been done in order to see and to show the different configurations and their impacts on the architectures. Yes.
Mm-hmm. But then I have a question myself, which is which utilities or developers are keen to provide the actual EE&S in order to validate these models, because I guess that might be something quite difficult to get.
The answer? Yes, it's kind of touchy there. Well, the idea was to build a tool, or a box, a toolbox for that, in order to assess such problems and to see if it's a driver in the optimization in the results we can obtain. and the results show that it is something that is interesting to look at. So the idea is that if someone is interested into such a study or to see the impact of its machine or its installations, we can discuss the input data and to improve the data itself. So yes, we have difficulties to obtain data. In fact, we don't really have them offshore for today. We use more or less onshore data, which are available. And for some of them, we modify the values for taking into account some specific considerations, like mean time to repair in an offshore sea or something like this. It's not the same time. But the tool is here. Yes.
The tool is here. But yeah, but the mean time to repair is something that you can get. More difficult is what is the actual cost for the utility or for the developers.
Oh yeah, okay, I see. It's a different aspect of the subject. Yes, in the optimization process, we have several costs that are taken into account. And as we're discussing now, the LCOE is the most difficult one to reconsider, of course, because it takes into account many things. As I said in my presentation, it's also coming from industrialization process until maintenance processes and so on. So the idea is to fit this economical approach with a partner if needed, and to take into account external constraints or industrial constraints or things like this. But it's on the table.
And people that have used your models, are there sometimes also banks or insurances?
Not for now. We have
not for now.
No, we have a partnership with some colleagues in the University of Nantes that are more on the economical aspects. So they depend on the economical lab, and they help us to to address such elements the right way, let's say, because we are not very specialists on that. So it means it's kind of a way we are developing now. In some ways, such optimization tools can give solutions, but if everything is erased by some economical engineering, it's useless. So we have to do it hand in hand, to see if all those drivers are relevant or not in the final things we look at. Yes.
Great. No, thank you for this answer. And you have a question now by Pierre Durand.
Yes, it's a long one.
It's a long one, so I have a few questions for Céline Boguet. Okay. Yes. Is there a commercial application of the electronical tool optimization developed with the University of Central Nantes?
It's not the University of Central Nantes.
No,
it's two different places for now, for so several months so far. Yes, but no, there is no commercial application for now. But we are, open to discussions and so on. But we do not have an extended version which could be somehow commercial or something like this. Okay. Yes, mooring have not been mentioned in the electrical network optimization. Is the tool only available for fixed offshore wind? So yes, it's a good question. The moorings are seen by some colleagues we are collaborating with. In fact, with the École Centrale de Nantes, which is in the LEA. I don't know in English how you pronounce that, but it's more hydrodynamics and the SEMREV were the site. And we are discussing moorings with them in different projects. And it could be introduced in a more general optimization view, like maybe DT Ocean Plus or other tools can do it. But for now, we are not dealing with the moorings approach. But in some ways, it's not a limitation on the fixed offshore wind. I mean, it could be also done for floating wind turbines, especially if we have different orientations, movements of the supports for the turbines, especially for the yaw control or the impact on the wake effects and so on. So
yeah, and about about the umbilicals, I guess they can be addressed like a special kind of connector, isn't it?
Yes, that's the case in some projects. As far as I know now, we don't have really much information on such elements. I mean, it's kind of on development. So for our optimization tool, we take into account the electrical aspects, which are quite known. If we look to the reliability aspects, maybe we have some work to do on that because it's a new tool, new elements. Not really know if it's relevant, if it's working correctly, if it's how it works. So, but it has, we can guess it has an impact on the performances of such configurations.
Okay.
In fact, Pierre, you had 5 or 6 questions. I'm looking at it. I'll try to give an answer to this one. What is the link between wake effect evaluation and electrical network optimization as wind turbines layout is not modified by electrical network module? Yeah, I understand in your question that maybe I didn't give you the elements to understand. It's not today something we introduce into the optimization loop, let's say, because it's time consuming. We can observe that on the layouts we obtain, and in fact, it's a layout only due to hydrodynamics, because it's due to the positioning of the turbines. We have different zones of interest in the park, and let's say we have the external ones that will produce more than the internal ones. And it means that if you have to give a trade-off between investment and reliability for your configuration, it could be a driver in the design of the layout, the electrical layout, and maybe reinforce it on the outside of the park and not inside the park, because the different turbines you get in won't produce as much as the others. So it's a kind of, just designing zones of interest, and it could be a driver at some point. That's the idea.
Okay. Thank you, Salvi. I don't see any
perhaps
other
I
question.
could add
Yes,
on a little
please.
bit to that last one. So the whole network optimization for the collection system is obviously a really hard optimization problem by itself. Then you have the layout and potentially the support structures, right? Especially if you have varied bathymetry, different sea depth, et cetera, all these things. And that's what makes kind of offshore wind farm full system design such a complex optimization problem. We've done some work on that at DTU, where you use a very simple model in situ for the electrical collection system, when you're actually co-optimizing then the layout with the electrical. And that's what we used, as I mentioned, in the reference wind farm, the Borsela one I mentioned. And then after the fact, then using a much more sophisticated optimization algorithm to do the detailed design of the electrical collection system. That's been the approach so far. And we're looking at ways in the research community, and I think this is a great area of research, is how to bring more of the important features of the detailed electrical system design upfront in situ with the layout design process. So that's an active area for work, and something that I think people like Xavi and myself are quite interested in.
Thank you, Catherine, for adding this. Yes. Okay. I don't see any question. Yeah.
And I think the industry is quite in demand of such method on how to design and which kind of level of model to use and various stages for the design. Yes.
I don't see any questions for Georges, but I know that it's quite also a difficult topic for people to apprehend from the beginning. I just want to stress that it's of course very challenging to put figures on some qualitative effects very often. So, but it's not the first time it's been done, because there was already this attempt in DT Ocean, and so in DT Ocean Plus things are going forward, and each time these thresholds are given by experts. And I think I will have a question that hopefully George will answer. That if the user considers he has also given expertise on the effect, on the stresses and so forth, if the user is also able to change these parameters in this assessment provided by DT Ocean Plus. But I don't see any specific question. No. And between us, among us. Okay. So I will thank you very much. I'm in the panel because given very interesting presentations and answered truthfully to the questions. And I thank the audience too, which went up to 56 people, and I think that's a very good audience by this time.